Welcome. Today I'm going to go through the hydraulic and pneumatic trainer. Today I'm going to walk you through the pre-job meeting demonstrations that you'll have to do with your instructor. One, you're going to have to explain the various components on the trainer that you're going to be working with. Secondly, you'll have to go through the safety checklist with the instructor. And we would also like you to demonstrate the first exercise to the instructor before you are cleared to start working on the trainer. We'll start with the hydraulic side, and then we'll go over to the pneumatic side. So let's have a look down and start at the beginning. Here you can see we have the reservoir of oil. Always make sure you check the oil level. This gauge is also a combination level gauge and a temperature gauge. The reservoir contains the additional oil we need to move through all of the hoses and components. It also serves to cool the oil when it returns back from the system. It has a filter strainer on the suction to also protect the pump from any debris being drawn out into it, and it also allows us to release any air as it settles in the reservoir. It has a vented filler cap. I'll just go through the system from the reservoir. Here we have the suction line. We have a suction valve, isolation valve, which we will be using in one of your labs to restrict the flow to the pump, which is not something you would normally do. On through here, you can see that we go to our pump. This is a positive displacement pump, gear pump. What a positive displacement pump means is no matter how much back pressure is created on this pump, it will always move the same amount of fluid. So there has to be a point that the fluid can go to. If it's not going through the system, through the components, then it'll have to have another path. If it's dead-ended, meaning shut off on the discharge while it's running, then something's got to give. You're either going to blow a hose apart or damage the pump itself. On the way to the suction line of the pump, we also had a vacuum gauge. We're going to use that to actually see any restrictions that are in the suction line when we're doing our labs. Also, we have an aeration valve. This is not a normal component you have in a hydraulic system, but this for the lab will allow us, if there is a restriction created, we will be able to use this needle valve here to allow some air to get in to the suction line of the pump. That's a bad thing, but we're just using it in this lab to demonstrate the noise that you would hear when there was air being drawn in to the pump. Also, if there's any leaks in your suction line, then that would cause air to get into the pump, and it would show as a reduction in the suction vacuum on this gauge right here. So from our positive displacement pump, the fluid's going to move up on through our system and out to the top of the board. You can see here, this manifold right here has identified pressure connections as well as return connections. So when we start to connect up our components, our supply from the pump will come off of any of these top pressure connections, these top four, and it'll go to our work components, then return to any of these four return connections, and then we'll go look back down below. And those return connections come back through our return filter into our reservoir. Now you may have noticed a couple of other paths that were options when I was going through. On the supply from the pump, I went up to that header, but there's another very important component right here, which is our adjustable pressure relief valve. As I described, if this pump has nowhere to go, as right at the moment I don't have a pressure connection above on that header, so if I was to start this pump, the fluid would have no place to go. So it would be dead-ended, we call it. So this T back here allows the relief valve, when it feels that back pressure being created, it will lift internally and allow the fluid to come back as well to the return reservoir. This relief valve is adjustable. That's not necessarily always the case on a hydraulic equipment, but we have it adjustable for the labs. So we pull, to adjust this relief valve, we would pull it down and turn it inward or clockwise to increase the spring pressure, and we will see an increase in the pressure setting that is now being transferred through the tubing to the pressure ports on our manifold. Now another component we have, I'm going to back that back off. At the end of every single exercise, I want you to back off the relief valve so the setting is as low as possible, the spring setting is as low as possible. Another component that you don't normally see, but a safety component that we have on this particular lab, is this bleed vent ball valve. I always want you to have this ball valve in the open position at the beginning and at the end of every one of your exercises. This bypasses the pressure setting of our relief valve, and when the pump starts off, the fluid will be allowed to flow again back to our reservoir. This is a safety in case a previous student has left the relief valve turned up too high. The first step you will always do for a lab when you start the pump will be to slowly close this relief valve. While you're watching this pressure gauge, the maximum pressure setting on this pressure gauge is 500 psi for this particular board. If it's higher than that, we can damage some of the components, the pump, some of the O-rings and fittings, and even hoses. So as you're closing that, if someone had this pressure relief valve turned up too high and did not back it off at the beginning of their lab, then you would see that gauge start to climb past the 500 psi setting, and you would reopen this and go and open that relief valve. Okay, we'll actually demonstrate that exercise in a moment. Before we do that though, I now want to go through with you your checklist that you're going to do. And you have this supplied with your instructions, as well as schematics for each of the labs. So when you ask for your pre-job meeting, it's important that you demonstrate and explain the components as I just have, and as well go through this safety checklist. First on the list, the oil level in the reservoir is at the correct level, all caps, joints, and plugs are tight. So make sure that this oil reservoir is not running low. If that runs low, then that could cause air to be drawn into the system as well. If that's the case, let the tool crib attendant know, and he will give you the appropriate hydraulic oil to top it up. Also check when you're starting to hook up your components that your hoses are connected according to your schematic that's given to you. Make sure that there's no hoses interfering with any of the operating cylinders as well. They're all clear. As I stated before, make sure that this relief valve is backed all the way off before you start. The system pressure gauge is properly connected. That's our reference to the system pressure. All the actuator paths are free. Check to see that all the guards are on the motors. And as well, you can see we have guards on the actuator here. When you are connecting up the hoses, you can see I have a hose connected here. They're a push connect, and they have a locking mechanism right here. So now I can't remove that hose. So if I want to remove the hose, I have to turn it back so that the pin lines up with the slot, and then I can remove the hose. So make sure each time when you connect that these are in the locked position. For this particular point, I'm going to remove both of my hoses so that for the upcoming exercise I'm going to demonstrate the pump is in fact dead-ended, because we're going to demonstrate the setting of the relief valve, which you'll have to do each time for each exercise. Always make sure that you're wearing your safety glasses when you're working on the hydraulic trainer. Visually inspect any hoses when you're working with them for any damage or cuts or nicks in any of the hoses. Make sure when you go to initially start the trainer that you're standing clear of it. as another safety precaution. Okay, so that's your safety checklist, and you'll have to demonstrate that with the instructor as well.